So we have this particular problem in front of us. It's mentioned that if 5x minus 15y is equal to 2x plus y, find the value of 3x square plus 2y square by 3x square minus 2y square. So we will approach it like any other algebraic equation. So what is given is 5x minus 15y is equal to 2x plus y. Now we will bring y is on one side and x is on the other side. So we can write this as 5x minus 2x plus 2x comes on this side. So we have minus 2x. This is equal to, we have positive y plus 15y. So this is what we get. Now 5x minus 2x will be 3x. This will be equal to y plus 15y, which is 16y. So we have 3x is equal to 16y. Now we need to prove this particular expression here, right? So we need it in a fraction form. So what we'll do is we'll perform a cross multiplication. So y will come on this side and 3 will go on the other side. So we will have x by y is equal to 16 by 3. Now this is the first expression. Now what do we do next? Well, we apply square on both the sides. So why did we apply square on both the sides? Because what do we need to prove? We need to prove this expression. Here what do we have? We have x square and y square, right? Both in numerator and denominator. That is why first of all we squared both the sides so that we can get x square and y square. So we have got this. That is, we are one step closer to the solution. Now once we have got x square and y square, let's see what are the coefficients of x and y. So the expression which we need to prove, in that the coefficient for x square is 3 and coefficient for y square is 2. So what we can do is we can multiply this x square by y square with 3 by 2. So we'll get 3 as the coefficient of x square and 2 as the coefficient of y square. So by multiplying both the sides by 3 by 2, what do we get? We get 3x square by 2y square is equal to 3 by 2 into 256 by 9. Now if we solve this, what do we get? We get 3x square by 2y square is equal to 128 by 3. So now can you answer this question? Which property of ratio and proportions do we apply so that we get this expression? Invertendo, dividendo, or componendo dividendo? What do you think is the right answer? Well, the right answer is componendo dividendo. Why do I say so? Because in componendo dividendo, when A is to B is proportional to C is to D, we can write it as A plus B by A minus B is proportional to C plus D by C minus D, which is very similar to this, x plus y by x minus y, isn't it? So we can get this term if we apply componendo dividendo. So let's apply componendo dividendo here. So what is happening is A plus B by A minus B. 3x square plus 2y square by 3x square minus 2y square. This is equal to this plus this by this minus this. So 128 plus 3 by 128 minus 3. Now if we solve this, what do we get? We get 3x square plus 2y square by 3x square minus 2y square is equal to 131 by 125. So we needed the value of this particular expression here. So we were able to get the value. And how did we do it? By first of all simplifying this equation, and slowly we moved on towards an expression which is exactly this. For that we also applied componendo dividendo property of ratio and proportion. Now let's see another problem. So here we have this expression which says x cube plus 3xy square by 3x square y plus y cube is equal to p cube plus 3pq square by 3p square cube by q cube. We need to prove that p by x is equal to q by y. So first of all, it's pretty clear that we need to simplify this equation so that we can get this equation. So we will approach it just like we approach any algebraic equation. So this is what is given to us. Now it's very important to notice the pattern in the question. So we have this particular equation here, and if you will notice, we have on the LHS x cube plus 3xy square by 3x square y plus y cube. Now if these two expressions were in a single line, then you can easily say that we could have written this or simplified this as x plus y whole cube, isn't it? Similarly, even on the RHS, we have p cube plus 3pq square by 3p square cube plus q cube. Even this, that is these two expressions, if they were in a single line, then we could have written this as p plus q whole cube, but they are not in a single line. Half of the expression is as numerator and half of it is as denominator. So our first approach is to get this denominator along with this numerator, that is in the same line as the numerator. How can we do that? If we apply invertendo, then what will happen? Well, the numerator will come to denominator and denominator will come to numerator's place. That will not solve our problem. So what else can we apply? Well, we can apply componendo. If we apply componendo, then we can have a and b. That is, if we have a by b, we can have it as a plus b. So a and b, both the numerator and denominator will come in a single line. But there is a small problem. In componendo, while we will have the numerator in the form of x plus y whole cube, but again denominator will still be unsolved, which will be a problem for us when we further simplify. So what we can do is we can apply componendo dividendo. In that what happens is we get the numerator and denominator both in a single line, even in the numerator as well as in the denominator. And so we have a better chance of solving this or simplifying this particular problem. So let's apply and see what do we get first. So if we apply componendo dividendo on this expression, what do we get? Well, componendo dividendo states that if a is to b is proportional to c is to d, then a plus b is to a minus b is proportional to c plus d is to c minus d. Here in this case, this entire can be considered a, this entire can be considered b. So we have a plus b by a minus b. So we actually got this entire expression in a single line. Similarly, because we applied componendo dividendo, so even in the numerator we got this entire expression in a single line. Similarly, if we consider this as c and this as d, then we'll have c plus d by c minus d. So we have got this entire expression. Now if we simplify this, then this numerator is not a problem because we have a plus symbol. So even if we remove the brackets, the symbols will not change. But in this denominator, if we remove the brackets here, we have a minus symbol outside. So these symbols will change. So we'll have minus 3x square y minus y cube. Similarly, in this case we have plus in the middle. So even if we remove the brackets, none of the symbols will change. But in the denominator, we have a minus symbol. So this will become minus 3p square q minus q cube. So if we remove the brackets, this is what we get. So we have minus 3x square y minus y cube, because we had a minus symbol here. Similarly, we have minus 3p square q minus q cube, because we had a minus symbol here. Other symbols remain same. Now the purpose of componendo dividendo application can be seen clearly. So we have this expression here, which is a very common algebraic expression. And what is that? Well, a plus b whole cube can be written as a cube plus 3a square b plus 3ab square plus b cube. Do we have it exactly in that format? A cube, we have x cube here. 3a square b, we have 3x square y. 3ab square, we have 3xy square. And then we have plus b cube, we have plus y cube. So we can write this as x plus y whole cube, isn't it? Now let's come to this expression here. So a minus b whole cube, what does it state? It states that a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. So a cube, here we have x cube, minus 3a square b, we have minus 3x square y, plus 3ab square, we have plus 3xy square, and then we have minus b cube, we have minus y cube here. So we can write it as x minus y whole cube. Similarly, let's come to RHS. We have p cube plus 3pq square plus 3p square q plus q cube, which is same as a plus b whole cube. So we can write it as p plus q whole cube. And this is p cube plus 3pq square minus 3p square q minus q cube, which is p minus q whole cube. So we can simplify this as this: x plus y whole cube by x minus y whole cube is equal to p plus q whole cube by p minus q whole cube. Now if we remove cube from both the sides, how do we do it? And why do we need to do it? Because we need to simplify it in that form. So we definitely need to remove these cubes. So we will apply cube root on both the sides. So if we apply cube root on both the sides, then we will get x plus y by x minus y is equal to p plus q by p minus q. So we have taken cube root of both the sides. But is this the final answer which we need? No, we need to further simplify it. But how can we further simplify it? Well, we have plus q minus q, we have plus y minus y, and we need to have a very simple expression. So if we apply a property which can again bring all these pluses and minuses in a single line, then we may have a chance of cancelling out some of these terms. So how can we do that? How can we bring these denominators and numerators in the same line? By applying componendo dividendo property. So we apply componendo dividendo property on this equation. So what do we get? We apply componendo dividendo. So we have a plus b by a minus b is equal to c plus d by c minus d. So x plus y plus x minus y by x plus y minus x minus y is equal to p plus q plus p minus q by p plus q minus p minus q. This is what we get from componendo dividendo. Now if we further simplify, what do we get? Well, what we can do is we need to remove these brackets. So we can write this as x plus y plus x minus y. There was no problem because we have a plus symbol. So there is no change in symbols. By x plus y, we have a minus. So once we remove the brackets, we'll have to multiply the minus. So minus into plus x will be minus x, and minus into minus y will be plus y. This will be equal to p plus q plus p minus q by p plus q minus p, minus plus p is minus p, minus q will be plus q. Now we can easily cancel out some terms. For example, plus y minus y and plus x minus x here, then plus q minus q and plus p minus p. So what do we have on the LHS? We have x plus x, that is 2x, by y plus y, that is 2y. So we have 2x by 2y on the LHS, and we have p plus p 2p by q plus q 2q. So 2p by 2q on the RHS. So this is what we have. So we can simply cancel out the 2's from both the sides. So what do we get? X by y is equal to p by q. But do we need this? Is this the final answer that we need? No. We need p by x is equal to q by y. So we need to have p and x on the same side and q and y on the same side. Right now we don't have that. But how can we get them to be on the same side? So we need p with x and y with q. And how can we do that? Which is the property which allows us to do that? Well, if we apply alternando, then what happens is the second and third terms get interchanged. So our second and third terms, these will get interchanged, and that's what we want. So we can write it as x by p is equal to y by q by applying alternando. So now we have got x and p on the same side and y and q on the same side. But still we don't have the final answer, because in this case x is in the denominator and p is in the numerator. Similarly, y is the denominator and q is the numerator on RHS. So we need to invert the positions. That is, we need the inverse of these two. So when we talk about inverse, which property can we apply? Invertendo. So if we apply invertendo, what do we get? Well, we get p by x. So numerators and denominators exchanged their places. So we have p by x is equal to q by y, and this is what we needed to prove. So we applied different properties of ratios and proportions to reach to the solution. So we applied componendo dividendo twice to simplify the equation, and we also applied alternando and invertendo. But before that, we first of all tried to identify the pattern in the question. The pattern showed that we could easily convert these terms into x plus y whole cube, x minus y whole cube, p plus q whole cube, and p minus q whole cube. So this is very important whenever you solve any algebraic equation. First of all, you need to identify the pattern and then you need to solve it. And once you have solved, then gradually you'll have to identify which are the different properties which you can apply to further simplify the equation.
Don't forget to subscribe to our channel. You can also register for free at DeltaStep.com to get all learning resources as per ICSE, CBSE, IB, Cambridge, or any other curriculum. over 5,000 amazing lectures across maths, science, English, and social science. Our unique interactive video technology keeps you engaged, and our iDictionary feature allows you to quickly revise any concept. Master each topic at your own pace with our adaptive practice technology and 1 million plus questions. Get instant answers and detailed solutions. Be exam ready by taking unlimited mock tests, performance analysis along with actionable feedback, personal tutors to resolve your slightest of doubts. That's not all. You also get amazing prizes like PlayStations, iPads, watches, and many more, along with certificates through our Earn As You Learn program. So at DeltaStep.com, learning is not just fun and easy, it's rewarding too. So register for free now.